Hi everyone, I am Madam Rosmaya. So in this video, we are going to discuss on tutorial 6. Okay, this is the first question. 4 different systems are shown in the figures. Okay, A, B, C, D. Okay, so we do A first. The question asks to draw the free body diagram for each of the bodies in each system, and then use Newton's second law to deduce an expression relating the mass, acceleration, and force in each system. Okay, for the first diagram, okay, given that A in this direction, okay, and then tension in the string is T, so this is action-reaction force, and then there is a force here pulling M1 and M2. Okay, we divide into 2 free body diagram. So the first one for M2, the force that act on M2 is T. Okay, and then for the second body, so the force that act on M1 is F and then T. Yeah? So this is the pulling force, and this is the T that comes from the action-reaction force between M2 and M1. Okay, so using reference A direction, acceleration, okay, to the right. So the sign for T will be positive according to the direction of A. Right? So using F equals to MA, so F is a resultant force. So the force resultant force for this diagram is T, and it is positive, equals to M2 times A. So this is the first equation. And for the second body, so F follow A direction, so F will be positive and T will be negative. So F minus T equals to M1A. Okay, next for B question, there are 2 tension in the string here. So this is the pulling force, and acceleration is to the right. Okay, so we divide into 3 bodies. Okay, for M3, the force that act on M3 is T2. Okay, and the force act on M2 is T1 and T2. Okay, and the force act on M1 is F and T1. So using the F equals to MA, so T2 will be positive because follow A direction. Okay, so T2 equals to M3A. Okay, for this one, T1 is positive, so T1 minus T2 equals to M2A. And for the third body, M1, F minus T1 equals to M1A. Okay, and for the C question, okay, so we have direction of A is to the right, and then another one for this M is downward. Okay, so the mass here M, and the force that act on the M here is weight of the of this block. Okay, so mg, which is equals to mg, and then tension in the string here, okay, T, and then this is another T. So this one pull the M downward. Yeah? Okay, so for the 2 bodies here separately, so for this M, the force that act on M is T. Okay, so this is the pulling force, which is the force act here is tension, so that's mean tension only. And for M, there are 2 forces, T, okay, tension in the string, and also the weight mg, capital letter M. Okay, so using F equals to MA, the first one will be T equals to MA. So T is positive because same direction as A. Okay, and then for the second body, capital letter M here. So MG is downward, same direction as A. So MG will be positive minus T. Okay, T upward, so minus T equals to M capital letter A. Right? Okay. And the last one, 2 body diagram here. So we draw separately. So for this one, M, tension in the string, and then the weight downward, mg. Okay, and this time the upward direction is a positive, because when the M sliding down, so it pull M up, so the direction of A is upward. And then for this one, the direction of A is downward inclined towards the downward inclined plane here. Okay, so the first one here will be T minus mg, because T is in the direction of A. So T minus mg equals to MA. Okay, for the bigger block, so we have mg downward and then R upward, reaction force by the plate, by the inclined plane here. Okay, mg direction is downward because this one is weight of the M. Okay, and direction of A is this way. So using the F equals to ma, okay, from Newton's law, so we need to resolve the component of mg. We need to resolve the component of mg. So this is angle given theta. So that means here will be 90 minus theta. 90 minus theta, because total angle in the right angle triangle is 180. So this one is 90 degrees. So here will be 90 minus theta. Okay, so the component will be, we use trigonometric ratio. Okay, this is 90 minus theta. Here also 90 minus theta, because this is the corresponding angle. And therefore, you also can use theta here. It's easier. So 90 minus theta here, and the angle here is theta, because right angle, right angle. So here will be theta. So we resolve the component mg sin theta, and then another one is mg cos theta. The two components of mg. So mg cos theta, because the line here adjacent to theta. This one is opposite to theta, so we use mg sin theta. Okay, so now we use the component t is along the inclined plane, same direction as A, okay, parallel to A. So how we write in the F equals to ma? So F is the resultant force. So the force direction along the A here will be mg sin theta minus t, because mg sin theta is in the direction of A. So mg sin theta minus t is opposite direction of A, so minus t equals to ma. Okay, so the question, this question not ask you to solve it, just write the equation, the equation form in the form of F equals to ma. Okay, so we go to question 2. We have 2 blocks here with mass 2m, and then this one is 3m. So this is on the smooth surface, and both blocks is pulled by F. So what is F? What is F? Okay, when F pulled, so this is a string, so there is a action reaction force here. So T that act on this both blocks. Okay. So the direction will be to the right, because pulling force here. Okay, now using the free body diagram. So for 2m, the force that act on 2m is T, okay, and it is T direction to the right, to the right, because the block moved to the right. So T to the right. Okay, so we form the equation using Newton's law, F equals to ma. So F is the resultant force. So therefore T equals to 2ma. So the mass of the block is 2m. Okay, this is equation 1. So for block 2, we do the same, but this time the force act on 3m, there are 2, which is this F, and then tension in the string, okay, from the action reaction force here. Okay, so using F equals to ma, so the F will be F minus T. Okay, because F follow direction of A, to the right. So F is positive. So F minus T equals to mass is 3m. So this is equation 2. Okay, now we use simultaneous equation solve for F. We solve for F. Okay, from these two equations just now. Okay, we combine both. We can use ratio. It's up to you to use what method. So let's say we use ratio method. So it's 2ma over 3ma, and then t over f minus t, and we cancel ma, so we get 3t. cross multiply 3t equals to 2f minus 2t, and rearrange the equation here to get f. So f we get equals to 5t over 2. So this is the answer, 5t over 2. Okay, easy, right? Okay, now for question 3. For question 3, the block X and Y are put side by side. Okay, direction is to the right because the force here is the push. The force the kind of force here is the pushing force. Okay, we push X, block X, and then both of them move to the right. Okay, so for free body diagram, okay, for object X, for block X, the force here applied to X, and then action reaction force between the two surface block X and Y is we call it as P. Okay, P. So P direction is action is to the X, towards the X. This another P is towards Y, because the direction of Y is to the right. Okay, so now we can the question asks to find P. So using F equals to MA, so F is positive because same direction of A. F is in the same direction of A. So F minus P equals to MA. So this is equation 1. And then for block Y, just P only, act on Y, block Y. So P equals to 2MA. So this is equation 2. And using the same method as question 2, so we use simultaneous equation. We substitute in question 2 into equation 1, which is P equals to 2MA. So we substitute into P here. So F minus 2MA equals to MA. And we solve for F, and it is equals to 3MA. Okay, so this is the answer. To find acceleration, so we bring 3 to the right side, so become MA equals to F over 3, and and P is 2 F over 3. So we substitute MA into here, this one, F over 3. So you get P, the reaction force, because the question is 1P, right? So we calculate for P. So P equals to 2F over 3. So 2F over 3. So this is the answer. Okay, next we do question 4. So we read the question. A gun fires 120 bullets per minute at a speed of 200 meter per second relative to the gun. So if the mass of bullet is 10 gram, the resulting force acting on the gun is ... So we are going to find the resulting force. Okay, so the solution using Newton's law. So Newton's law, we use F equals to dmv over dt. We start with the Newton's second law. Okay, from the definition of Newton's second law, which is resultant force is directly proportional to the rate of change of momentum. So momentum is mv. Okay, so we can B is constant, which is 200 meter per second. So this is constant. So the changes is in the mass of the bullet, because the gun fires 120 bullets per minute. So there is a change in mass here, dm by dt. Okay, so the mass of the bullet is 10 gram for a bullet. So there are 120 bullets, 120 bullets. So you multiply by 10, 120 times 10. Gram convert to kilogram, 200 meter per second. Okay, substitute into V here. And the time taken is per minute. So per minute convert to hour. So 1 times 60 hours. Okay, so the answer is 4 Newton. So this is the answer. Now we go. Okay, now we read question 5. A tractor of mass 1000 kilogram tows a trailer of mass 1000 kilogram. The total resistance is 4000 Newton and is constant. 1/4 of the total resistance acts on the trailer. Initially, the acceleration of both the tractor and the trailer is 2 meter per second. And then finally, both of them move with the same uniform speed of 6 meter per second. So what is the force on the tractor along the tow bar when the acceleration is 2 meter per second, and then when the tractor and trailer move at 6 meter per second? Okay, so to solve this question, it is better to draw the diagram. Okay, so now we draw it. The first question, we are going to find the force on the tractor along the tow bar when the acceleration is 2 meter per second per second. Okay, so imagine this is the trailer, the mass is 1000 kilogram. This is the tractor, the mass also 1000 kilogram. Okay, so the force, this force is the engine thrust from the tractor. So the tractor move forward, okay, with this force. So therefore there is a tension tension in the tow bar here. So this is action reaction force, actually the tension here. Okay, then the friction given is 4000 total resistance. So 1/4 is for the trailer. Okay, look at the question back. So here 1/4 of the total resistance acts on the trailer. So total 4000 Newton. So therefore 1000 friction for this trailer, and then for the tractor the remainder will be 3000. Okay, 3000 total, 4000 friction. Okay, so acceleration is given 2 meter per second. So initially they move with the acceleration 2 meter per second per second. Okay, look back here. So initially the acceleration of both the tractor and the trailer is 2 meter per second per second. Okay, so now we draw the free body diagram for the first for the trailer. So for the trailer, the direction of A is to the right, so that means tension will be positive and friction will be negative. So T minus 1000 equals to MA. So we use F equals to MA. So the M 1000 and the acceleration is A. So we calculate, we get T equals to 3000 Newton. So this is tension in the tow bar. And then we are going to find the force. So for the second diagram, which is tractor, so is force minus T from F equals to MA. So force is in the direction of A, so it's positive, then minus the T, and then don't forget we also have friction here, friction 3000. So there are three forces act on the tractor. So that means F minus T and then minus friction. So F minus T minus friction equals to the mass of the tractor, also 1000, times the acceleration 2. So the tension we calculate already in the first part for the trailer. So we can substitute T into here, also 3000. So F minus 3000 minus 3000 again equals to 1000 times 2 is 200 Newton. So we get the F here, the value is 8000 Newton. Okay, so this is answer for A, question A. Okay, next we go to question B. Question B, the questions one, force on the tractor along the tow bar when the tractor and trailer move at 6 meter per second. Okay, so this is mentioned in the question here. Finally, both of them move with the same uniform speed of 6 meter per second. So initially it moved 2 meter per second. This is acceleration. And then finally, both of them move with the same uniform speed. So both of them reach same uniform speed, 6 meter per second. So this is understood that the acceleration is 0 because uniform speed. So from 2 meter per second, and finally the acceleration becomes 0. Okay, this is the hidden information we get from here. Uniform speed here means that acceleration is 0. Okay, so what is the force? So for the next situation, the acceleration now reach 0 when the speed is uniform, which is 6 meter per second 6 meter per second. Okay, because this speed, acceleration is 0 because uniform. So now we divide into two, separate the body diagram. Okay, for the first one, the force act is T minus friction. Okay, equals to 0. This time acceleration 0, so equals to 0. So when this happen, so the tension is only 1000 Newton. Okay, tension only 1000 Newton. Just now 3000. Okay, when this reach when acceleration 0 and the speed 6 meter per second, so the tension becomes 1000 Newton. Okay, for the second part, F minus T minus 3000. Okay, F minus T minus 3000 equals to 0 also. Okay, because at this situation, Okay, so we substitute the 1000 just now into the equation. So we get F is 4000 Newton. So that's mean the force act on the tractor here is 4000 Newton. Okay, so that's the answer. Okay, so now we go to question 6. State the action-reaction forces in Newton's third law of motion when a bat hits a ball and then book rests on the table. Okay, so for bat hits a ball, so the action-reaction force from Newton's third law is action force is force of bat on the ball, and then the reaction is force of the ball on the bat. Okay, then for question B, book rest on the table. So from the Newton's third law, the action force is weight of the book on the table. And for reaction force is normal force of the table acting upwards on the book. Okay, so this is the answer for question 6. Next, question 7. We are going to find change in momentum when the object moves from P to Q. Okay, the object moves from here. This is the initial point. Then move to Q. Okay, angle is 45 degrees, okay, given, and the speed projected from P is V, okay. Okay, so the question wants momentum, so let's say momentum is P, okay. So at the Q here, direction of V will be tangent to the point here, in this direction. Okay, this is V final and this is V initial. Okay, so we are going to find the component of V. Okay, so for the horizontal component, the V cos 45 degrees, okay, because the line here is adjacent to 45 degrees. So we use trigonometric ratio, we get V cos 45 degrees. So the component of V for VF also the same, the same because horizontal component. Okay, then for the vertical component, will be V sine 45 degrees, V cos 45, so will be V sine 45 degrees. Okay, same, only different direction for the initial and final. Okay, so same this one, V sine 45, here also V sine 45, only different direction. Okay, because this is symmetrical, the projectile curve is symmetrical. So the change in momentum, this is symbol for change in. So change in momentum will be final momentum minus initial momentum. Final momentum is P at Q minus P at P. Okay, so we choose the horizontal component. So the change in momentum will be momentum is m times v. Okay, mass time velocity. So m, the object, let's say the mass of the object is m. So m times v cos 45 degrees. Okay, at the final mv cos 45 degrees. So this is horizontal component, mv cos 45 degrees minus final minus initial. So final is v cos 45 degrees minus positive v cos 45 degrees. So we get 0, because they are same value. Okay, so they are same direction when final minus initial, so we get 0. So this is change in momentum for horizontal component. So it doesn't has any effect on the overall resultant momentum. Okay, for the vertical component, is on because they are this different direction. So final is v sine 45 degrees. So that's mean negative m times the velocity v sine 45 degrees. Because this is change in, so we minus the upward direction here. V is positive, so m minus positive mv sine 45 degrees. So that's mean minus mv sine 45 degrees minus mv sine 45 degrees. So we get negative 2 mv sine 45 degrees, because they are opposite direction. So minus final because opposite direction, minus final, and then minus the initial. Okay, so initial is positive direction, so we get negative 2 mv sine 45 degrees. Okay, so now we solve for the sine 45, we get 1.41 mV. Okay, then to get the momentum, so we use Pythagoras theorem. Okay, for these two, Pythagoras theorem. So the change in momentum will be negative square root of negative 1.41 mV. Okay, bracket squared, so we get 1.41 mV. Okay, So this is the answer for change in momentum, 1.41 MV. Okay, so next we go to question 8. Okay, the stone and earth system. The stone and earth system, this is before. You can refer to the question given in the tutorial 6. So when a stone is dropped to the earth surface, so actually the earth is very big in size, but because just to get the idea of what happened, so I just draw it small earth here. So the stone is dropped to the ground, okay, or on the earth. This is before. So the total of the momentum because of the earth is 0. So the P total the momentum total of momentum before is equals to 0. The stone at initial before it is released, before it is dropped, also velocity is 0. So that's mean momentum is m times v. So total momentum will be 0. Okay, and then when it is released, so the stone start to move with velocity v. Okay, so earth remain the same, is stationary, okay, at rest. So after the momentum will be mv here, and then the mass of the earth, let's say capital letter M. So to see the difference between the mass for both of them, so we use one capital letter, one small letter. So the velocity also the same. We choose V small letter for stone, and the velocity of earth capital letter we use for to represent the velocity of the earth. So this is what we are going to find. We are going to deduce later what is V of the earth. Okay, so now m times v plus mv, total momentum. Okay, so we don't know this v yet, whether positive or negative, so we just put plus. So if we don't know, to determine the sign later, okay, because v is unknown, v is unknown, we don't know yet, so we just put plus mv. At final result, then only we can know what is direction for v. Okay, so now these two we combine together. Okay, we use the principle of conservation of momentum. So the momentum before is equals to the total momentum after. So total momentum before is equals to the total momentum after the both situation here. So before 0 equals to mv plus m for the mass of the earth times the velocity of the earth. So we rearrange the equation to get this v, and we get equals to negative mv over m. What can we state here? So we know that the mass of the earth is very large, very large. Okay, it's very large. So m is we use this symbol. Okay, m is larger compared to the mass of the stone. It's logic, right? Then therefore from the relationship here, the m large, so the v will become very small. It's approaching 0. So I go back to the question. So if m is large, so v will be approaching 0. Okay, v approaching 0. So there is nothing happen to the earth actually. So the velocity of the earth remain 0. Because the stone is very small. When it hit the earth, so it doesn't has any effect on the earth. The earth doesn't move at all. So the velocity of the earth is 0. So if you think of the logic, the logic, earth is so big and the stone is so small. So when you drop the stone and the stone hit the earth, so what happened? It doesn't has any effect on the earth. So proven by the principle of conservation of momentum. So the v is approaching to 0 value, or in other words, the speed of the earth is 0. Okay, so that's the answer. Now we go to question 9. Okay, state Newton's laws of motion, and then use the second and third laws to show that the total linear momentum of a system which consists of two colliding bodies is constant if there is no external force on the system. Okay, so first we are going to use Newton's second and third laws of motion to deduce the momentum is conserved in a collision. Okay. Okay, this one Newton's laws of motion, there's mean three Newton's law. So you can refer to your textbook here, the answer. So we go to the second, direct to second question. So we are going to use Newton's second and third laws of motion to deduce momentum. To state that momentum is to deduce that momentum is conserved in a collision. Okay, so this is the figure shows two bodies A and B. We have A and B, masses MA and then MB respectively. Okay, this is before collision. The speed is UA and the speed for B is UB. So during collision, when they collide, so this is action reaction force given by FA FB. Okay, action reaction force. Okay, and then after collision, the velocity of A is VA and then VB. Okay, VA and VB. Okay, so they move in the same direction here, same direction. So when A collide with FB, so the direction of VA and VB, we can get it later. Okay, later. Okay, so now action reaction force FA FB. So according to Newton's third law, okay, of motion, during collision, force of FA equals to negative force of B. Okay, there are action reaction force, right, from Newton's third law, so they must be opposite in direction. So FA is equals to negative FB. Okay, so FA is force of A on B, and then FB is force of B on A. So they are opposite in direction. Okay, so now this is equation 1. We let it as equation 1. Okay, then for force A on B causes the momentum of B to change. Okay, so we use change in momentum. Okay, force to relate with the force. Okay, so change in momentum of B will be MBVB minus MBUB. Okay, so we can factor out MB, so bracket MB minus UB. Okay, so force of FB on A causes the momentum of A to change. Okay, so we use the change in momentum of A, so MAVA minus MAUA, so final minus initial, so V first and then U. Okay, final minus initial, so MAVA minus MAUA, so we factor out MA and bracket VA minus UA. Okay, so now from these two change in momentum, we use second law. So Newton's second law state that change in momentum, rate of change in momentum is equals to the force. So now change in momentum just now for FA and FB, for object A and at B, so we substitute into this equation. Okay, we substitute into the Newton's second law. Just now is this one is from action reaction force. Okay, now we use Newton's second law for the force, which is change dp by dt, and dp is change in momentum over time taken. So the time taken is the time interval of time that A and B are in contact during collision. So this happen, if you can imagine, this happen very fast, right? So this is delta t, time taken during happen when the collision happen. Okay, so we substitute the MA bracket VA minus UA over delta T, and then the just now FB is MB bracket VB minus UB over delta T. Okay, so we equate them because in equation 1 they are equal, so we equate these two, FA equals to FB, where we use Newton's second law, okay, to relate with the F during the collision. Okay, so now we can cancel out delta T. Okay, then we factor out this. Okay, when we cancel this out, so we get this, and then we rearrange the equation. So MAVA minus MBVB, so we bring the MBVB to the left side, and then MAUA we bring to the right side. They become positive. So MAUA plus MBUB. So what is this? This is momentum. M times V is momentum. So the total of momentum after collision, so because this action reaction force just now, right, negative, so the total linear momentum is plus minus, right, the plus, so it's still total, but the VB is in negative direction. Okay, so this is still total linear momentum after collision. and then it's equals to total linear momentum before collision. So it is proven. So it is proven that linear momentum is conserved in a collision. Okay. So done. We prove this. This is proven. Okay, now we go to question 10. A mass of 5 kg is acted on by a force F which changes with time t as shown in the graph. So after 5 seconds, after 5 seconds, the momentum of the mass increased by 40 kg meter per second. So what is the value of x? So we are going to find this value of x. So this is the ft graph. From the ft graph, it is understood that area under the graph will give you change in momentum or impulse. Okay, will give you impulse. Okay, area under the graph. So we use impulse which is equals to area under the graph. Okay, and area and impulse also is change in momentum. Change in momentum. So we use half times area of a trapezium. Area of a trapezium, half times 5 plus 3. 5 plus 3, the two parallel side is 5 plus 3 times the height of the trapezium x. So we get, and it's given that 40 meter per second. So we go back here. So momentum of the mass increased by 40 kilogram meter per second. So this is change in momentum. So we equals to the 40. So we can get the value of x equals to 10 Newton. Okay. So impulse is change in momentum. Ft, impulse is Ft, and Ft is equals to mv minus mu, change in momentum. Okay, so that's the answer. Next, we go to question 11. An object of mass 5 kg moving with an initial velocity of 2 meter per second on a smooth horizontal surface is acted upon by a force F along its direction of motion. So the force F varies with time t as shown in the graph. And what is the velocity of the object after 12 seconds? So the velocity after 12 seconds. So this is ft graph. Again, this is ft graph. Okay, if ft graph, area under the graph is equals to change in momentum, and equals to the impulse. Impulse, and impulse is ft, and ft is equals to mv minus mu. Okay, change in momentum. So we use impulse equals to change in momentum, or in mathematical form is ft equals to mv minus mu. Okay, so area is area of a triangle. This area is 0, so area of this one will be area of a triangle. So half time base 10 and the vertical distance is 10. So half times 10 times 10 equals to mv minus mu. So 5, this one we get 50, and then the mass is 5, and then the speed initial m minus u. So initial speed is 2. So we go back to the question. Is given okay. So here given the initial velocity is u. Okay, 2 meter per second, and then time taken is here until 12 here. Okay, so we substitute, we go back to the answer just now, v minus 2. So we solve for v, we get 12 meter per second. Okay, so that's the answer. Okay, so we finish finish the tutorial 6, all the question, and you hopefully that you can understand, and bye.